Hi students, this is Alex here. In this video, we are going to discuss a problem based on Euler's theorem on homogeneous function. In the question, it is given there is a function u which is a homogeneous function of degree n and in terms of x and y, and we have to prove the following expression. Since it is a homogeneous function of degree n, we can say by Euler's theorem x into dou u by dou x plus y into dou u by dou y equal to nu. Let's keep this as a first expression. Now we are going to do partial derivative of this expression with respect to x. So let's write here differentiating the expression 1 partially with respect to x. Now we have to follow product rule for this. So let's keep the first term as it is. Derivative of this with respect to x will be its second order, dou square u by dou x square, plus keep the second term as it is, dou u by dou x, and derivative of x is 1. We have followed the product rule. Here once again we have to use a product rule here. So first we will write the y as it is. In this term, derivative with respect to x will become dou square u by dou x dou y, plus we have to keep the second term as it is, and partial derivative of y with respect to x. Y is a constant now, so it is 0, because whenever we do partial derivative with respect to some variable other than that variable remaining a constant. So here we are doing with respect to x, so y is a constant, so derivative of the y will be 0, and on the other side it is equal to n is a constant as it is, and partial derivative of u with respect to x will be dou u by dou x. So let's rewrite this term, x into dou square u by dou x square plus dou u by dou x plus y into dou square u by dou x dou y, and this last term is 0, and on the other side it is n into dou u by dou x. Let's take this as the second expression. In the same way, we are going to differentiate the equation 1 partially with respect to y. We have completed partially with respect to x. Now we are going to differentiate partially with respect to y. So differentiating 1 partially with respect to y. Let's copy this expression here. So it's easy to differentiate x into dou u by dou x, x into dou u by dou x plus y into dou u by dou y equal to nu. So we are going to start the differentiation now. As usual, we have to use a product rule here. So x we have to write as it is, and this derivative with respect to y will be dou square u by dou y dou x, plus second term we have to write as it is, and the derivative of x. Now we are doing partial derivative with respect to y. So x is treated as constant, so its derivative will become 0. Then again coming to the second term, again we have to follow the product rule. So write the first term as it is. Derivative of the second term is dou square u by dou y square, plus write the second term as it is, and derivative of y with respect to y is 1, and on the other side n is a constant, and partial derivative of u with respect to y is dou u by dou y. So let's rewrite this term, x into dou square u by dou y dou x, plus this term is 0, then y into dou square u by dou y square plus dou u by dou y equal to n into dou u by dou y. This is our third expression. Since in the proof what we have to get, we have x square into dou square u by dou x square. So in this second expression, we have the second derivative, but we have only x here. So throughout the equation, we are going to multiply with x. So what we are going to do is second equation into x, we are going to multiply. So what will happen? This will become x square into dou square u by dou x square. X square into dou square u by dou x square. Then plus x into dou u by dou x. So plus x into dou u by dou x. Then xy into dou square u by dou x dou y. So we have to multiply with x. So xy into dou square u by dou x dou y. Then finally on the other side, n x into dou u by dou x. So n x into dou u by dou x. So we will take this as the fourth expression. So we multiply every term by x. In the same way, this third equation we have to multiply in terms of y, because here in the proof we have y square into dou square u by dou y square, but in this third expression we have second derivative, but we have only y. So throughout y, if I multiply, I will get the required term. So by multiplying with y, we get the first term will be xy into dou square u by dou y dou x plus y square into dou square u by dou y square plus y into dou u by dou y equal to ny into dou u by dou y. Let's take this as the fifth expression. Now we are going to add both. Now fourth expression and fifth expression we are going to add. So here we will write this term first. So this will become x square into dou square u by dou x square. Then we see these two terms. Once it is a homogeneous function, dou u by dou x, dou square u by dou x dou y and dou square u by dou y dou x, both are same. So we will write it here plus 2xy dou square u by dou x dou y. Here we can specify, that is dou square u by dou x dou y is same as dou square u by dou y dou x, because it's a homogeneous function. So we can write this as dou x dou y. So when I add with this, it will become 2 times. Okay, then we will write the another term, that is this one, plus y square into dou square u by dou y square. So plus y square into dou square u by dou y square. And apart from this, the remaining terms are x into dou u by dou x plus y into dou u by dou y. So that we will write it here, plus x into dou u by dou x plus y into dou u by dou y. And on the other side, we have nx dou u by dou x plus ny dou u by dou y. So n we can take common in the next step, nx dou u by dou x plus ny dou u by dou y. So we finished adding 4 and 5. After this, we can replace this term. You can see in the first step, from the first equation, x into dou u by dou x plus y into dou u by dou y is nu. So from 1, this can be written as nu. So I will write this is from 1. And the first three terms, let's write as it is: x square dou square u by dou x square plus 2xy dou square u by dou x dou y plus y square into dou square u by dou y square, then plus nu equal to, other side as I said we can take n common. After that again x into dou u by dou x plus y into dou u by dou y. So once again, how this is replaced as nu, this entire term can be replaced as nu. So once again, the first three terms on the other side written as it is, and even this plus nu is also written as it is, and on the other side it is n is outside, apart from that we have nu. So this can be written as n square u, and this nu I can take to the other side. So first three terms we have written as this. The other side we have n square u. Then this nu will become minus nu when it goes to the other side. So here we can take nu common. When nu is common, the remaining will be n, and when this is common, remaining will be minus 1. So let's rewrite according to the question. It is n into n minus 1 u. So in the question they have given, prove that x square into dou square u by dou x square plus 2xy into dou square u by dou x dou y plus y square into dou square u by dou y square equal to n into n minus 1 u. So since it is a homogeneous function, we had a first equation by Euler's theorem, then we partially differentiated with respect to x, then with respect to y, then each we multiplied with x and y and we added together, and we substituted the expression 1. From the expression 1, x into dou u by dou x plus y into dou u by dou y as nu in two places, then finally we got the required proof.